Hello, my name is Rob Reynolds. Welcome to Mat-073. This is section 2 of chapter 6, and today we're going to be talking about radicals and rational expressions with radicals and converting from exponential to radical form and vice versa. And then we're going to look at how to solve some or simplify some expressions with radicals. So the first thing you need to remember is a basic rule. If you had a squared times a cubed, that's a to the fifth. So you're rewriting the base and adding the exponents. And the same thing is true for rational exponents, which, by the way, is rational exponents just means you have a ratio or a fraction for an exponent. So this says rewrite this without using a fractional exponent. So we can write this as a radical. Roots grow on the bottom, so this is actually pronounced the third root of m to the first, which is the cube root of m. And again, the way I remember that is this is pronounced the cube root of m. So let's see, this is m to the 1/3, and this is the root is on the bottom of that fraction. So here this says the square root of 9 x to the 8th, and then it's all raised to the first power. So this is the root. And so I'll write that as the square root. And being raised to the first doesn't mean anything. So that's really the square root of 9 and the square root of x to the 8th, which is really just 3x to the 4th. And this is the fifth root of x, y squared, z. And I don't think we can do much with that, so I'll just leave that final answer. The only thing you may want to talk about is whether this should be an absolute value form or not. Rewrite with rational exponents. So this is going to give you the radical, and they want you to change it to exponential form. So we could write this as to the 1/3, because remember the roots grow on the bottom. So that's to the 1/3 power. You could write that as 4 to the 1/3 and then x to the 1/3, but I'm not convinced that that's any more simplified. So this would be 5y squared divided by x all raised to the 1/5 power. I think I would leave it in that form. Good. The author did likewise. So again, roots growing on the bottom. So this is the nth root. So this n is pronounced, and this whole thing is pronounced the nth root of a to the m. By the way, it doesn't matter if that m is on the inside or outside. Sometimes it's easier to write it on the outside, but it means the same thing. I think I could prove it to you. Let's look at the cube root of 8 squared, and my proposal is the same thing as the cube root of 8 being squared. So let's do this first. So the cube root of 8 squared is 64, and what number times itself is 64? Well, that's 4, because 4 cubed really is 64. Then if I take the cube root of 4 cubed, that should give me back to 4. And then over on this side, this says let's take the cube root of 8 first, working inside the parentheses. So the cube root of 8 is 2, and 2 squared is 4. So again, it doesn't matter where that m is located. I think it's easier if you take the cube root first. So let's do it. The cube root of 8 is 2. And then last I'll square it. Oops, that looks like 22 now. So the cube root of 8 is 2, and 2 squared is 4. This says let's take the square root of 9 first and then cube it. The square root of 9 is 3, and 3 cubed is 27. So 4 and 27 is what the author got as well. Rewrite as rational exponents. So roots grow on the bottom, so I'm going to put this as 5/3 and 3xy to the 2/5 power. And author agrees. Negative exponents mean reciprocal. So if you have 2/3 to the negative first, that's 3/2. And the same thing works for rational exponents as well. So this says let's take the cube root of 8 and raise it to the negative second. Well, the cube root of 8 really is just 2, and 2 to the negative second. Well, this negative says put it in the denominator, and the 2 says square it. So let's repeat this process. This says the square root of 9 and raise it to the negative 3. So this is 3 to the negative third. So flip it and cube it is 1/27. And then this x to the 1/5 kind of just hangs out there. I don't think I can do anything with that. You could probably write it as x to the 1/5 all divided by 27 for final solution. Over here, this negative says reciprocate it, so I'm going to say 2r over 3t, and now it's raised to the 3/4 power. I could try to take the 4th root of that, but I don't think you're going to get very far with a 2r, so I think I would probably just stop and leave it. Let's see what the author did. Good. Author agrees, and 1/4. Good. So here are the basic rules. You rewrite the base and add the exponents. If you're dividing, you subtract. Power raised to a power, you multiply. You can distribute, and over multiplication and division. So you're going to rewrite the base and add the exponents. 2/5 plus 1/5 for a whopping 3/5. Here you're going to rewrite the base and subtract. But in order to subtract, I think we're going to need common denominators. So I'm going to choose 4s as a common denominator. So I'm rewriting that 1/2 to be 2/4. Mathematically, that's equivalent. So this is 2/4 minus 1/4, which is 1/4. Oops. How about just m to the 1/4? I could write that. Problems with my pen today. Here, this I can distribute to each term. So this is really x to the 1/2 raised to the 3/4, y to the negative 1/3 raised to the 3/4, and then I have this power raised to a power. So that's going to be multiplying, and when you multiply, you just go straight across. So 1 times 3 is 3/8. Y to the negative, well, I could cancel these, 1/4. But the negative says I'm going to throw this into the denominator. So x to the 3/8 stays in the numerator, and then the y goes in the denominator with a positive exponent. So the rule is, if you see a negative exponent, put it where it's not and change the sign. And looks like author agrees on all 3 solutions. So again, simplifying radical expressions, we want to convert expressions to exponents, add or subtract, and simplify. So you can pause the video and read through this. Let's see if this works. Use radical exponents to simplify. So let's change this to 4/8, because that's an exponential form, and 4/8 reduces to 1/2, and then you could rewrite that as the square root of x. Let's do this again. Rewrite this as an exponent, so this is really to the 1/8, and then if I distribute to every term, 4/8 reduces, and 6/8 reduces. This reduces to 1/2, this reduces to 3/4, but it might be nice to get common denominators. So I'm going to change this a to the 2/4. And the reason why I wanted a common denominator there is because now I have a common root. So the rule of thumb is if they give you radicals, we're going to write the final answer back in radical form. So let's not leave it in exponential form. If I start with a radical, give the answer as a radical. So I'm going to leave this as the 4th root of, and this a term is being squared, and the b term is being cubed, and I'm just going to hang on to those. I'm not going to do anything to that, so just leave it a squared b cubed, final solution. So I'm basically kind of just reducing those fractions as I go along. And yep, author kind of agrees here. We should just leave these things in radical form. This one looks difficult because this 3/8 is really, 3/4 is really a 6/8, and I can't do anything with this numerator the way that it is, so I'm going to switch gears. Instead of going to 3/8, I'm going to look down here and try to simplify, because you could rewrite the base and subtract the exponents. So x to the, let's get common denominators, and remember we're going to subtract. So I'm going to choose common denominators of 12 and multiply numerator and denominator of this guy by 3 and get a 9. Multiply numerator and denominator by this guy by 2, because 6 times the 2 will give me 12. So both 9/12 reduces to 3/4 and 10/12 reduces to 5/6. And the nice thing is now I've got a common denominator of 12. Let's repeat the process with the y's. So y to the 7/8. Let's keep this 7/8, and I'll subtract off a common denominator of 8. So I have to multiply this 4 by 2. So 1 times 2 is, so 2/8 reduces to the 1/4. And 7/8 take away 2/8 is 5/8. And now I'm looking for a common denominator. It looks like I've got to go up to 24. So multiplying by 2 gives me a -2, and a y. Multiplying this by a 3, because 8 times 3 is 24, so that gives me a 15. So now I've got the 24th root of, well, I've got a negative exponent here. I don't think we want to leave answers with negative exponents, so I'll write this maybe as the 24th root of y to the 15th over x squared. And I think I'll leave that. Let's see what the author says. Now, they've changed the problem. Oh, how convenient of them. They changed the 5/6 to a 1/6. And of course, that's going to change these answers, and now they have a positive. So they worked a different problem than we did. I think I did it okay. Let's move on. Using rational exponents to simplify. Oh, so this is the same thing. I'm going to write this as roots grow on the bottom. So this is the 4 goes on the bottom. That 2/4 reduces to 1/2, and then you could write this as the square root of 3x. Again, let's do this. 9 divided by 3, because this is pronounced the cube root. So I'm going to write that 3 on the bottom, and 9/3 is just 3. So I suppose we could distribute this. I wonder what the author says is more simplified. I don't know. Maybe we'll find out. I don't know which is more simplified, A or B. I'm not even going to guess. I would take either answer. This right here is y to the 1/2, and then it's raised to the 1/4. So the power raised to a power rule says we're going to multiply those together. So we'll have y to the 1/8, which is the 8th root of y. So it says simplify. So again, I'm curious on that second one. Oh, yep, they did simplify that. There's the simplified form. I had a 2 here. This was a 2. This should have been a 2, making this a 6. So sorry. But that's what they did. They distributed that out. And then their answer for C maybe is on the next slide. Good. The 8th root of y, which I think we got the same thing. Yep. The 8th root, yeah, of y. All right, very good. Well, I hope you found that this helpful. If you have questions, this is a very difficult section, so please email me with your questions. I'll be happy to help.